Hello guys, welcome back to Civil Engineers YouTube channel. Today in this short video lecture, I will guide you for 5 big mistakes in beam construction. If you are working on construction site or if you want to build your house, so be aware from 5 big mistakes in beam construction. So if you have any question related this short video, so you can comments, I will respond you. The first one is guys, that is about beam size mistakes. So most of the construction I saw there that some people are new, they don't know about building construction and they want to build your house, so they don't know, so therefore the size of the beam should not be less than, remember this is the first big mistake, the size of the beam should not be less than 9 inches width and 12 inches depth. Okay, so this is D and this is width. Okay, so this is specially for beam. Okay, if that is top beam or plinth beam, okay, in both of them the width should not be less than 9 inches, but in most of the construction I saw many construction they are providing 9 inches 6 inches width of the beam and 9 inches depth of the beam. So the beam depth should not be less than 12 inches and the width should not be less than 9 inches. Okay, so these are very important point, but most of the construction I saw there, if you are working on construction site, so it should not be less than this, but it you can increase, but it's depend on the structure load. Okay, the second big mistake is especially for steel bars mistakes. Okay, so how steel bars mistakes, remember guys, especially in beam or in slab. Okay, so in most of the construction I saw, they don't know what is lapping length. Guys, lapping length especially in beam, column, slab. Okay, so you should know the proper place, that what is the proper place to provide the lapping length. So what is lapping length? So first of all I will tell you about the lapping length. So let me write here. Okay, so guys, you can see from factory we have 12 meter steel rod. Okay, so this is the standard length, or you can say 40 feet. Okay, so this is specially steel rod length. Okay, so this is the length of steel, right? Okay, so sometime we want to increase this length, so this is 12 meter or 40 feet, so therefore if we required for example 60 feet, okay, 60 feet are around about 15 meter, etc. So therefore we are providing the lapping here at this place to extend the length of steel rod according to structure design. Okay, required length. So therefore guys, this is the other steel rod, for example if its length is for example 5 meter. Okay, so therefore we are making here lapping. Okay, so this is called lapping. Guys, you can see this is called lapping length. Okay, lapping length. So remember where you can provide the lapping length. So therefore we are binding these steel rods with each other to extend the steel reinforcement length. Okay, so therefore the lapping length should not be less than, this is a lapping. Okay, so if that is beam, column or slab, so if you are working on construction site or if you are new and you don't know, so you should provide lapping length not less than 60 D, where D is die of steel rod. Suppose this steel dia is 12 millimeter. Okay, so therefore 12 millimeter, or you can say if that is for example 12 millimeter is equal 0.5 inch dia. Okay, so therefore 0.5 inch dia, so it means 60 multiply 0.5 inch. Okay, so therefore we require 30 inches lapping length. Okay, it should not be less than this if that is beam, column or slab. Okay, so therefore this is the bigger figure. Okay, this is the bigger figure especially for lapping length. Okay, if that is beam, column or slab, it should not be less than this. Next guys, remember as I told you before, suppose this is one column, okay, and this is other column, especially in beam. Okay, in the beam, suppose the beam is going same like this. Okay, so this is beam, suppose this is continuous beam here at this place. So here guys, you can see this is the length, total span, if that is 20 feet or 25 feet, anything. Okay, so therefore remember one thing guys, that here the lapping should not be provided at the bottom. Guys, you can see this is mid. okay, and this is L by 4 distance, this one and this one. L by 4 total length, suppose the total length I have 20 feet, so therefore mid is here 10 feet, and L by 4 is 5 feet, here this is 5 feet, so 10 plus 5 plus 5, so we have totally 20 feet. So therefore the laping should not be provided at the bottom portion of this beam, so don't provide the laping here. This laping should not be provided at the bottom, but in upper portion you can provide the laping, okay, this is very important. And compression zone you can provide the laping in upper portion for floor beam or in plinth beam, but in tension you can't provide because here we have maximum bending moment. Here guys you can see, don't provide the laping length at the distance of L by 4, because here we have maximum shear stresses or negative bending moment. Here we have negative bending moment, here also we have negative bending moment, here we have positive bending moment, okay. So therefore when the load comes on the top of this, so it makes a shape same like this, okay. So therefore we have negative bending moment here and positive bending moment here, but you can provide the laping after L by 4 and don't provide L by 2 distance. As I told you before, this is tension zone, but you can provide here at the junction, especially on the top of the column. So this is column, okay, and this is also column. So don't provide at the distance of L by 4 and at the distance of L by 2, but in upper portion and tension zone you can provide. So this is laping length, important points, okay. Next guys, if this is column, suppose this is RCC column, inside this we have steel reinforcement, okay. So especially for the column also, don't provide the laping length at the bottom. Also don't provide, because here we have a slab, also we have here floor, so don't provide here, and also don't provide here. But we have H, suppose H is here 12 feet, so H divided by 3. So here guys you can see we have 4 feet, okay. So don't provide at the bottom, but at the distance of 4 feet you can provide the laping here, okay. But don't provide at the distance of H by 2, where H by 2 is 6 feet. That's why, because the total height is 12 feet. So at the distance of H by 3 you can provide, but don't provide here, and also don't provide here, but especially you can provide at this place, but not at the bottom, not at the end of the slab, okay. So also this is especially for beam. So these are steel reinforcement mistakes that most of the people they are doing. And next guys, remember at the bottom you should provide maximum numbers compared to its upper portion, because concrete is weak in tension, so therefore we are providing more quantity of steel reinforcement in the bottom portion, which is tension zone. In compression zone you can provide minimum steel rods compared to its bottom, because this is compression zone and concrete is strong in compression. Next guys, about the hooks, okay, the third mistake is especially for hooks. As I told you in many videos that guys, you can see this is a beam, suppose this is floor beam or plinth beam. So in that guys we are providing hooks like this, okay. So this is the best design of hooks, and if you are providing the hooks same like this, okay, like this guys, as you can see. So here guys you can see this is a 90 degree, and here guys if you see, so this is 135 degree. So from here to here we have 135 degree, so provide it on 135 degree. So this is the wrong method. That's why, because it cannot resist with earthquake, okay. And this laping length should not be less than this hooks, this hooks length should not be less than 75 mm, or you can say 3 inches. This is very important to know about this point, okay. Next guys, this is especially for hooks, okay, and hooks should be provided alternately, okay, opposite of each other, not provide at the same direction. Next guys, you can see here, if you see, let me focus the camera first. Okay, next guys, the stirrups mistakes, as I told you before, okay. The stirrups, suppose here I have a beam, as I already discussed here. So at the distance of L by 4, okay, L by 4 means at the distance of 5 feet, because we have negative bending moment. So therefore the stirrups should be provided closely here, especially at this place, or where we have laping, okay. Here also same spacing, but after L by 4 you can increase the spacing like this, okay. How? Suppose this is a beam, okay, this is L by 4 distance, this is also L by 4 distance. So at this place, that's why, because of here we have a column, okay, also we have a column, okay. So at the distance of L by 4 you can provide closely about 100 mm. It's depend on the structure load, or you can say 4 inches center to center, okay. But after this is L by 2, so from this L by 4 to L by to the L by 4 distance you can provide closely, but after L by 4 you can increase this, okay. You can go up to 150 mm to 200 mm It's also depend on the structure load, okay, depend on the beam design, okay, or depth of the beam inside steel reinforcement, etc. So this is especially for stirrups mistakes, okay. This is the 4 1. So the other one is, guys, especially here we have about 7, but I have main 5 big mistakes. So therefore no problem, because I extended the mistakes here because we have also. So already, if you see the 5th one, I have already discussed for the spacing mistakes. If you see the spacing, I already discussed in the stirrups hooks, I already discussed. So the spacing is being done, especially here. So now concrete mistakes. Remember, guys, for normal residential building, okay, so for normal residential building, I am recommending you that used here M15 grade concrete, okay. For M15 grade concrete mean 1:4 ratio. But one thing more, guys, for beam, column and slab, beam, column, slab, foundation, okay. So used here M20 grade, where M20 is 1:1:1.5:3, 1 part cement, 1.5 parts sand, and 3 parts are aggregate or crush, okay. So this is very important grade of concrete, because steel can't make steel can't give you full strength, okay. That's why, because when we combine the steel with concrete, okay, so inside concrete we are providing the steel reinforcement, which is called reinforcement, okay. So therefore concrete is very strong member, especially in construction material. So therefore concrete ratio should be provided according to the structure load, but it should not be less than M15 normal for normal residential building. But for the commercial building, it should not be less than M20, okay. Next, guys, here, so this is the 6th number. So this is the 7th number, curing mistakes, okay. That's why, because of if you provide less curing for the structure material, for the structure members like beam, column, slab, so you cannot get the full strength. So therefore for brick masonry, okay, so minimum you can use 7 days, but I'm recommending you can go up to 12 days, okay. You will get the full strength. Therefore, guys, for each member, if that is beam, column, slab, so don't use less than 13 days, okay. So 13 days are very important for curing, okay. That's why, because most of the people, they are doing curing up to 5 to 6 days or 4 to 5 days. They said that yes, now it's okay, but this is one of the big mistake, but especially in hot season, okay. So in hot season you can use up to 15 days, 18 days, okay. That is if that is possible, but normally you should not less than 13 days. But for winter season, you can go up to why not 12 days or 10 days. It's okay for that. So hope this short video can help you, because we have more knowledge in this practical video to guide you for big mistakes. Thanks for watching. See you in next video. Goodbye.